So we're looking at finding the distance between 2 points. And if it's on a coordinate plane, there's an easy way to do it based on what we know about Pythagorean Theorem. Okay? If I were to take a straight edge and try to measure the distance between these 2 points, it's not going to help me as far as what the coordinates or actually the distance between the coordinates on this grid would be. So to find this, if you imagine a triangle, and this being the hypotenuse to your triangle, I could basically try to move my point until I get to where I'm right below this point. Okay? If I count the distance between the points, I have 1, 2, 3, 4, 5, 6, which would be the leg of my triangle. I have 1, 2, 3, 4, 5, 6, 7, 8, okay, which would be the other leg of my triangle. And basically, I'm now asked to find the longest leg of the hypotenuse. If you recall from the Pythagorean Theorem, I can find the hypotenuse of a triangle by using the formula a squared plus b squared equals c squared. Now again, it doesn't matter which one I call a or b. These both refer to the legs. In this situation, I'm going to use 6 for a, I'm going to use 8 for b, and I'm looking for c, which is the longest leg. Squaring 6 would give me 36, plus squaring 8 gives me 64. If I add the two together, that's going to give me 100. 100 is the value of c squared. That number wouldn't make sense if I placed it here for my hypotenuse, because it doesn't make sense if I have a leg of 6, a leg of 8, and a leg of 100. So remember, we're not looking for c squared, we're looking for c. The final step would be to take the square root of both sides. Remember, when you take the square root of a number, it undoes squaring a number. So technically, this cancels out, leaving me with c. Square root of 100 is 10, which means that the length, or distance rather, from this point to this point is actually 10 units. And that's how you would use the Pythagorean theorem to find the distance between 2 points on a coordinate plane.